ogive. Remember, your ogive is a cumulative graph. For percentiles, we're going to be able to find out, like, what is at the third percentile, what is at the fourth percentile, 20th percentile. Sometimes they give you a graph of percentiles, and you just interpret this one off the graph. So from the ogive, they ask you what score is at the 62nd percentile. My first period, I can't really shuffle lights because it's so dark outside still. So the 67 percentile, you're going to kind of have to estimate where is the 62nd percentile. Come across, these are percentiles over here, and try to come down and get as close as you can to the actual score. My board's a little off again as usual. So try to get as close as you can to the actual score. If I ask you what is at the 30 percentile, what score would you tell me is at the 30 percentile? What score would you say? What are they going by? Try to figure out where they're going. So here's a 600, here's a 900. So are they going by hundreds? Are they going by hundreds? 900, 1,000? Are they going by hundreds here? Between 1200s, 13, 14, 15? So kind of estimate. Bring the 30 down and kind of estimate between here. So maybe between 13 and 14, what would you say? What would you estimate it to be? 1,400, close enough to the 13 to 14. I'd say probably a little closer to the 13. But give me some kind of a ballpark estimation. I don't expect you to be exact on those, but you will find other percentages exactly. So if you can figure out approximately where it's going. You can also reverse this. You can go the opposite way. You can be given a score, say for instance 2100, and ask what percentile does that fall in. So kind of walk it across, and it's very close to the 100. Maybe that's the 99th percentile. You can do it the other way on this graph as well. An ogive is built to keep growing. So it's just accumulating all the scores before it. I have to redo my board. Hopefully it rested up since Friday. All right. God bless you. The ages are the most powerful one, and that's okay. Now, this part is important. To find the percentile that corresponds to a specific entry. So if I have 800 entries and I want what percentile does the 44th entry come to? You're going to take the number of data entries that are less than that number. Divided by the total number of data entries, you get a ratio. Part over whole, right? You get a small decimal. Then you take that decimal and you multiply it by 100. That gives you a percentage. So for example, and your data has to be lowest to highest. That's why sometimes when you put it into your calculator, the L1, you want to do a sort A. So if you put it in your L1 and you want to sort A, that puts your data lowest to highest. So for the data in example 2, find the percentile that corresponds to 30,000. Now, these were written in thousands. Here's my 30,000. I'm going to count the number of entries that are less than 30,000. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 entries less than 30,000. I'm going to put it over the total number of entries. Count how many entries there are. So that was 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 25. Part over whole. Do not count this one. I want the number that corresponds to less than that. Now, doesn't this give me a decimal? This gives me a decimal, and I get 0.36, and I'm going to take this, because 25 goes into 100 times 9. When I multiply this by 100, this gives me the 36th percentile. There's my percentile. That means this is greater than 36% of the ones before it. Okay? So if you want a percentile that corresponds to, say 31, how would I do 31? Ten over 25. Good. It's just one more than that one. Times 100. So this will be 40th percentile. Comes at the 40th percentile. At the 26. Now be careful of their 26. When they do the 26th percentile, there's two 26th percentiles. So when they do the 26th percentile, how many are less than the 26? 4. See how some of these repeat? So if they say the number at the 26, which one should I use? Use the first one unless they say otherwise. There are 4 less than that over 25. So this is at the 16th percentile. 16% higher than the ones before, than the other data sets, than the other data. Okay? So be careful when they use a double one. Just take the first one, count how many come before. So all you have to do for percentile. That's about as exact as we're going to get on that. Now, here's the meat of this. My z-scores. This really should be in a whole unit by itself, because this is what we use for the rest of this whole thing, for the rest of this course. Your z-scores are a way of calculating your standard deviations. Okay, the z-score represents the number of standard deviations of a given value that fall from the mean. To find it, we use a certain formula. Now, this is what this means. Here's your mean, or your population mean. Here's your 1, 2, and 3. Here's your -1, -2, -3. Well, we're okay when they fall on these guys, right? But what happens when they fall right here? There is a score that falls between 0 and 1, right? There's many scores that fall between 0 and 1. What happens when I'm 0.01? I don't know what that score would be. What happens when I'm 1.8? I do have a z-score that would give me that, but I don't know how to calculate that. So what this is saying is this. This is a normal curve. All the negatives fall here, but your standard deviation is always measured positive. So these guys now, we're going to consider them z-scores. All to the right, they're positives. In the middle, my z-score is 0 because it doesn't move off the mean. There's no movement off the mean. What this means is this. Say I get a test, and the average of my test is 70 with a standard deviation of 5. That means this is 70, 75, 80, 85. So this is 65, 60, 55. What about a score of 63? Where does that fall? Well, I can kind of judge and say, yeah, it looks like it's falling between -1 and -2. Almost halfway, right? I should be about -1.5. Now, this little nice formula tells us exactly. It says, take your x value, 63, subtract the mean, which was 70, divided by the number of of what your standard deviation is. Now, when I subtract this, won't I get a negative number? 63 minus 70. So 63 minus 70 is what? Negative 7. If I put this in my calculator, 7 divided by 5, I get a z-score of negative 1.4. Oh, I was pretty darn close when I said it came almost halfway between, right? Triple This allows me to find every z-score on this chart because my grades on my test weren't all by 5s, were they? Like someone gets a 98, someone gets a 62, someone gets a 59, someone gets a 73. They don't all go by 5s. Up until now, we only did the ones that you could read off the chart. From here on in, we can do any of them. So if I have a grade of 81, I want to know what that z-score is. Estimate it. What do you think it's going to be? Look at the chart. What do you think an 81 is going to be? It falls closest to which one? 2. To the right of 2 or to the left of 2? A little bit to the right of 2. Here's my 80. Where does my 81 fall? Right here. There's my 81. So I say, take my x value, subtract my mean, and divide by my standard deviation. So I get 81 minus 70. This gives me 9 over 5. Whoops. Sorry, 11. A little off today. This gives me 2.2. So I knew it was going to be positive, but I didn't know exactly what number it would be. So with this formula, and this is a formula we will use all the time for this, to find a z-score. Now, you know how your coefficient of variation enabled you to find like some kind of a relationship between two objects or two things that weren't really related? We could look at how much they varied within themselves and which one had the most variation. Z-score enables us to get even closer to that. So let's take a look at their example. They barely hit on this, but they have to do this now because when we do probability, we need to use your z-scores. And when we do this, we sketch all the time. The mean speed of a vehicle along a highway is 56. So pull out your information with a standard deviation of 4 miles per hour. You measured the speed of 3 cars. You found out car 1 was going 62 miles per hour. Car 2 was going 47 miles per hour. And car 3 was going 56 miles per hour. You want the z-score that corresponds to each one of their speeds. Questions? You with me so far? So let's work this out with me, guys, because this is important. First thing I'm going to do is sketch my graph. I'm going to have you do sketches until you kind of get the hang of where everything's falling. So my mean is 56. My standard deviation is 4. 60, 64, 68, 52, 48, 44. Okay, so I'm looking at my first car. My first car is going 62 miles per hour, smack in the middle of here. Between 60 and 64. What should my z-score be? 1.5. So let's see if that's true. I take my z-score, I take the value, this is my x value, 62 minus the mean, divide by my standard deviation. So this gives me 6 divided by 4, This, in fact, gives me 1.5. 1.5 standard deviations above the mean. So my z-score tells me it's 1.5. Z-scores are always rounded to 2 positions. Now, I'll go through the other ones and then we'll go through what does this actually mean in terms of a percentile. Because they kind of put it in the percentiles, but they don't tie the percentile into it. But we will. I get to the second one, 47. 47, a little tougher for me to kind of figure out. It's not halfway. So I use my z-score formula. And I notice when I subtract the smaller minus the larger, don't I get a negative? And shouldn't I be getting a negative standard deviation here? Okay, so let's subtract this. I get negative 2.25. And that kind of looks right, doesn't it? Okay, so I'm negative 2.25 standard deviations away from the mean. My third one says I have a z-score of 56, an x-score of 56. Oh, it's right here. It's falling on my mean. Does it vary off my mean at all? So what should my standard deviation be, my z-score? 0. So let me see if that's true. My z-score says take this x value minus my mean over my standard deviation. And sure enough, adding up to 0. Now, how does this figure into percentiles? Your book doesn't exactly handle this part, but if you remember from your chart, remember all the percents that are in there? The percents go from 0 to 100%. This is the part that's not in your book. The percents go from 0 to 100%. Because the area under that whole thing is 100%. If you took yours that you did in Algebra 2 and you end up all those little percentages, they would come out to 100%. Now, if I start at the left and I accumulate all my area here, that should tell me what percentile I am at. Now, we have a nice handy table that does this instead, because I really can't add up these percentiles because I don't know where this is going to fall. So I'm going to use my table instead. Now, when you come back tomorrow, I should have a table for you. Today, I don't know if I have a table. Hang on. I might. I just might. That you get in the back of your book. You don't have to question it, I apologize. But it'll save you time from going back and forth in your book. Okay, this is in the back of your book. You kind of looked at this the other day real fast on A16. You need another one? It's in the back of your book on A16. So what it tells you is this. It's always looking at the area to the left. So when you do this, this is how we're going to read this. This is important. This is going to help you get your percentile for this. So you're going to look up, it has a positive side, it has a negative side. So when we look up and that one is negative 2.25. So watch how we look this up. We say, it shows this piece, and then it shows 0.00, point, well, on the negative side, it shows 0.09, it goes down, 0.08, 0.07. If you added this to this, it's just that last decimal place. So on the negative side, come down to negative 2.2. Go across until you see 0.05, because negative 2.2 plus 0.05 gives you negative 2.25. It's just giving you your hundredths position. It's kind of like money. This is your tenths position, that's your pennies. Okay, so take that area off of that chart. Well, it's a negative number, negative 2.25. Find me the 0.05 and tell me what number you get in that, where they intersect. So, what's 0 what? 0.0122. Good. Did everybody find this? Yes? So if I take this decimal and I multiply it by 100, that means I'm at the 100.22 percentile. That means I'm not a whole lot larger than the rest, than a lot of the ones before it. Right? That means I'm pretty low on this. Let's look up your z-score of 0. We're going to spend more time with this, but I want you to look up the z-score of 0. When you look up the z-score of 0, what area under the curve does it cover? Either side of the table. What's the area for 0? Look at the 0.00. Look at the positive side. It's the first one on the list. Which would be what? 50%. And isn't that half of my data? I'm at the mean. Isn't it halfway through? 50%. Let's look up this guy. 1.5. 1.5 is over here. I'm looking for what percentile I am. From 0 to 100. Should I be more than 50%? Okay, so you're looking up 1.5 here. You're on your positive side. 0.00 over here. So it's 1.50 is what we're looking up. What is it? 9.41. That means I am at the 94.41 percentile. I am better than 94.41% of the people, of the speed of the vehicles. I'm faster than 94.41% of the vehicles on this road. Okay. Now, remember what we talked about. We make this chart a little wide. Normally, your curve is real small on the edges. But if we put the 3 and the 2 in here, we have no place to write anything. And it kind of distorts it a little bit. So we spread this out. But remember, up to 2, anything above 2, below negative 2 is unusual. It's got a real small percent sticking out there. So we kind of have to gauge that. So when we look at percentiles, our z-scores can help us figure out a percentile. They go through the z-scores, but they don't actually put it for a percentile. Is it kind of making sense a little bit? Let's try another one. All right. Monthly utility bills in a city. Okay, the monthly utility bill in a consider you have a mean of 70 and a standard deviation of 8. Pull this information out. So the first thing we're going to do is graph this. Remember, we have 3 positives, we have 3 negatives, and the middle is the mean. So 70, add 8, just keep adding 8. I want you to get used to this, and subtract 8. Okay? This is where they're going to go across the mean. Now, you have 3 bills. You have one at 60, one at 71, and one at 92. You're going to vary off the mean. So the first one is a 60. What's nice about this is it tells us right away, what's my z-score? Is it going to be a positive or a negative? A negative. So if I forget which way to subtract, and I can't remember, is it the population mean minus the x? Is it the x minus the mean? I want to subtract so that it's negative, don't I? So therefore I want to subtract the smaller one minus the larger one. My z-score says x minus the mean over the standard deviation. Over the standard deviation. So now I'm going to take this guy, which I thought I had a calculator. Probably left it somewhere. We're going to subtract this guy. Stay with me. And we get a z-score of negative 1.25. Does that make sense to me? Am I between the negative 1 and the negative 2? Now, look up that area under your curve. Negative 1.25. Tell me what you get. So you're looking up negative 1.2 and you're going across to the 5. 1056. Thank you. So I move my decimal. So I am at the 10.56 percentile. That means my bill is larger than 10.56% of the bill.
So when you have a number like 1.25, you just round the 5 down?
No, you leave the 5 there. You're looking up this. You're looking up negative 1.2. And then when you add this in, see this decimal? Consider these to have zeros here.
Alright, so you just drop that last number.
So this last number is belonging right there. You kind of hold it off and find your last number up there. So 1.25 says this. Look up 1.2, and then the 5 comes from this up top.
But you just don't include the 5 when you're looking for that.
Well, you can't because you can only look up the 10th position. The 1's position you have to find up here. So isn't this like $1.20 if you think money?
Yeah.
And this is 5 cents. So $1.20 and 5 cents give me 1.25. Kind of think of it like that. Okay? Okay, 71. 71 is slightly above my mean. So I'm going to say z is 71 minus 70 over 8. Isn't that going to put me into the positives? Barely right over to the 0. So I do 71 minus 70 divided by 8. I have a z-score of 0.125. Now, this is tricky on your table. I can only round my z-scores. John, this is where I have to round to 2 positions. Because up here, they only give me 2 positions. So what should I round this to? I have to round to this position. 0.13. Now, how do I find this on my chart? If I look at this, right in between here, I'm looking up the 0.1, and then I'm coming across to the 0.03. So look that up on your chart. 0.01 and the 0.03. What do you get? say? 0.5517. Sorry. I heard you said it's 17. 0.5517. So it's going to say 0.01 tenths and 0.03. That means, aren't I over 50%? Doesn't my graph show me I'm over 50%? My graph shows me I'm over 50%, so I'm about this percentile. My bill is higher than 55.17% of all the bills. And the last one is a 92. That's pretty far up there, isn't it? That should be unusually high, isn't it? Anything above 2 is unusually high for this scenario. So I am 92 minus 70 over 8. And what does that z-score come out to be? Anybody come up with it? $2.75. Make sure you do this in parentheses if you're putting this in your calculator. And isn't that unusual? It's almost 3. So, but in terms of percentile, isn't this most of my graph? So isn't that going to be a high percentile? What'd you get? 99 percentile. 0.7 percentile. Thank you. And the 99.7 percentile. Okay, tomorrow we'll compare two data sets. But I want you to just digest this part tonight. This is a really, really important part, the z-scores.